A good day to everyone. So we're here to conduct hypothesis testing, making use of the z-statistic. And if you will look at our worksheet, we have a column of values for uh, the variable x. And these values actually correspond to a sample which is taken from some population, which is known to have a mean of 20 and a variance of 12. So the first question should be, why are we using the z-statistic if our sample size is less than the threshold for large sample, which is considered uh, to be equal to 30, which is the common value for large sample, or the minimum value for large sample. Um, well, we are using the z-statistic because the variance and consequently the standard deviation for this population is actually known, which in this case, the variance is given as 12. And so the standard deviation can easily be found to be equal to square root of 12. So it is because of that reason that even though we have a small sample, we are still using the z-statistic rather than the t-statistic. And so let's begin our testing by specifying our null hypothesis, which states that the population mean is equal to 20. So in this case, what I'll do is I'll try to copy the value of the parameter, which is the population mean, equal to 20, and put it as our um, null hypothesis. Uh, our alternate hypothesis should state the opposite, which in this case would say that the population mean mu is not equal to 20. Now, um, if you have used the data analysis toolpak of MS Excel before, then you probably have noticed that we can only do z-testing um, for MS Excel if you have two samples. In this case, we have only one sample, so what we do is we do a little bit of adjustment, and the adjustment is by um, inserting an extra variable, in this case capital Y, and then I will set at least one value for this variable. And in this case, it will be enough to set the value for y to be equal to 0. So again, it's only necessary to assign at least one value for the variable that we are inserting alongside the x variable. And so we're now ready to use the um, data analysis toolpak for MS Excel. And we do that by clicking the data tab and then clicking the data analysis. So the important analysis tool for us is the z-test, which you can see is already highlighted here. And so we press OK. And then what I will do is I will try to insert the values for the x variable into the slot for the variable 1 range. So I do that by highlighting this column for the x variable. And automatically, those values will be specified in the slot for variable 1 range. I do the same thing for the y variable. And so there you have it. For the hypothesized mean difference, we just key in the value of 20 for this slot, which is basically the value of the population mean that is given to us at the beginning of this exercise, as well as in the null hypothesis of our test. For the variable 1 variance, we key in the value 12 because that is again given at the beginning of our exercise. For the variable 2 variance, we cannot put the value of 0 here because that will not be accepted by the z-test for the two sample for means. Instead, we choose a value that is very close to 0, but not equal to 0 itself. So let us just choose the number 0.001. So that should be enough. And then I put a check mark on the labels square because I have included in our table of values the names of the two variables themselves. The alpha value that you see here, which is 0.05, corresponds to the fact that our level of significance is equal to 5%. So the only thing we have to do now is specify the location of our summary output, which in this case I will specify to be at the cell G1. And so with that done, we can now carry out our z-testing. So press OK, and immediately we will see the summary output for our test. But I will do a little editing of the summary output because some of the stuff here are actually not important or not relevant to our conclusion. So in particular, I will delete the column for the y variable. So I will delete this. For the row called hypothesized mean difference, I will just edit this to hypothesized mean. And then for the title of the summary output itself, I will change this to one sample for means. So we are now ready to go over our result. The mean for our sample is 18.6. The known variance is 12. The sample size, which corresponds to the number of observations, is 15. The hypothesized mean is 20. And the important item here now is the z-statistic, which in this case I will highlight by a yellow color. And this value is going to be important for comparison to our critical z values. Now, if you will notice, our alternate hypothesis makes use of the not equal to symbol. And so what is important to us right now is the item for the z-critical two-tail, which is given as 1.959964. Now, take note that since we are using a two-tail test, what is actually being given here to us is the region of non-rejection, which in this case will have a left endpoint of negative 1.959964 and a right endpoint of 1.959964. Now, the z-statistic, which is given to us, and which I have highlighted in yellow color here, is between the two endpoints of the region of non-rejection. So since z equal to negative 1.56427 is within the interval of non-rejection, we conclude that we do not reject the null hypothesis 80, and there is no evidence from the sample to say that the population mean is different from 20. Now, we could have arrived at this conclusion by also looking at the p-value for our z-test, which in this case I will also highlight uh, in yellow color. So the p-value is equal to um, 0.117754, okay? Which in this case, you will notice is much greater than the level of significance, which is equal to 0.05. Okay? So let me indicate that fact. Okay, so the p-value being greater than 0.05, which denotes our 5% level of significance. Okay, will also confirm our initial conclusion not to reject the null hypothesis and conclude that there is no evidence coming from the sample that the population mean is different from 20. And so that ends our hypothesis testing. And thank you for listening, and I'll see you in the next video.